Okay, welcome to the first video in our Unit 3 Topic 1 Bivariate data. We're just going to look at classifying variables. So what's really important in this is for us to just quickly go back over our Year 11 classifying. So we can classify data under two headings. We can classify it as numerical, so that means that the data has numbers, or we can classify them as categorical, so categories. Our categorical can further be split into ordinal, and that means it has an order. You know, first, second, third, strongly agree, neutral, disagree, and then we have nominal, so no order, just categories. Numerical can be split into two, so we have discrete and continuous data. Now these two, if we remember, discrete are set numbers. So that means, for example, shoe size. So you can only get like a size 8, a size 8.5, size 9, 9.5. You can't get a size 9.75 shoe. However, continuous data is when you can get any number along a number line. So I can measure height, weight, things like that. I can be 180 centimetres tall. No, 180 centimetres, or I could be 180.625 centimetres tall. I can be that high. Height can be measured like that. So, continuous data, anywhere along that number line. So remembering this, I've got these three different associations. So these are investigating the association between two variables, which is bivariate data. We're going to have a look at these two variables and just decide. So first of all, what the two variables are and whether they're categorical or numerical. So in this first one, are females more likely to vote for the Greens party than males? So we've got females and males, so that's gender, and that's a category, so categorical. Then we've got whether they're more likely to vote for the Greens, so voting, so that's like yes or no. So that's also a category, yeah? Probably don't have to underline category there. Is the new treatment for headache more effective than the old treatment? So we've got new treatment, old treatment, so that's type of treatment. That's a category, old, new. Just stick with cat. And then we've got whether or not it's more effective. Now, how would you measure the effectiveness of a headache treatment? Well, you would measure it in how long it takes for that headache to be gone, to disappear. So that's time, the other variable, and that's numerical. Then we have, are younger people more knowledgeable about environmental issues than older people? So straight up we have age, yeah? Old, young, somewhere along that continuum, numerical. And knowledgeable about environmental issues. Now, how would you sort of rate knowledge about environmental issues? Well, you would probably give them a quiz or a survey, something like that, and they would get some sort of score that rated them and rated their level of knowledge. So that their knowledge as a score would be numerical. So we can see that our first statement or investigation is looking at investigating two categorical variables. Our second investigation is looking at a categorical and a numerical variable, and our third investigation is looking at two numerical variables. Now the last bit we need to kind of look at is explanatory variable. So these actually have names, and we write EV for short, and response variable. Now these are the two types of variables that we're looking at. Once we've decided whether they're categorical or numerical, we then decide whether they're the explanatory variable or the response variable. And there's always one or the other, particularly when we're dealing with bivariate data. So the response variable, obviously the response that's given, but the explanatory variable is what explains the result, the response. So that means that the response is dependent upon the explanatory variable. So the explanatory variable is often called the independent variable, and the response variable is often called the dependent variable. That also means that independent is the x, dependent is the y variable when we're graphing. Okay, so when we look over here, are females more likely to vote for the Greens party than males? We've got gender and we've got voting. Now, basically, we're looking at whether they're more likely, females more likely than males. So that means that gender is going to be our explanatory variable, because whether we say yes or no, whether we respond with yes or no to voting, may be because of our gender, and that's what we would be investigating, whether that is a correct association. When we look at this next one, we've got the type of headache treatment and the time it takes for the headache to go. So looking at how effective it is. So the time it takes is going to be dependent upon the type of treatment that you have. So, yeah, the time it takes is going to be the response variable, okay? So however long it takes, that's how long. And what we think explains that is the type of treatment that you have. With our last one, younger people being more knowledgeable about environmental issues than older people, we're basically saying, does age affect how much knowledge you have? So the amount of knowledge you have is the response. And we're saying, does your age explain how much knowledge you have about environmental issues? So it would be the explanatory variable. Okay, so please make sure that you have copied down all of the examples, written down in your notes, etc. Written down any questions that you have so that you can ask your teacher when you go back to class. Okay, thanks.